When I was a teenager, I gave up playing tennis to focus on my medical studies. My tennis coach was very understanding, encouraging, almost relieved now that I think about it. Well, in any case, I'm now a consultant neurosurgeon. I've been working for the NHS in the UK for the best part of the last 25 years. But I never lost the passion for tennis. And recently, a video of a young player completely blew my mind. Here it is.
A bit late. Up. No. Yeah. Up. Good. Yeah. Go. Good job. Go. No. Forward. Yeah. Good. Great job.
Did you notice anything unusual? If not, rewind and watch his backhand. This kid doesn't have a backhand. He has a right hand forehand and a left hand forehand. He switches the racket between hands and hits with equal power and accuracy from both sides. This is one of the rarest things you will see in sport. True hand co-dominance or ambidexterity. And it made me wonder, if an athlete can train both hands to the same level, could I do the same thing in surgery? Could any of us deliberately close the gap between our strong hand and a weak one? Today I want to answer that question properly. I will start with why we have a dominant hand in the first place, then look at what the evidence actually says about training the non-dominant hand, and finish with the strategies that generally work. No gimmicks, just what the science supports. If you're finding this useful, subscribing really does help. It means more people get to see videos like this. Why do we have a dominant hand? Well, let's start with the numbers. Around 90% of humans prefer the right hand for complex tasks. About 10% use the left, and only about 1% are truly ambidextrous. That is one of the most consistent findings in human biology. And it starts before birth. This bias shows up surprisingly early. In the womb, fetuses already favor one thumb over the other. Isn't that fascinating? By just 4 weeks after conception, gene expression patterns in the developing nervous system shows left-right asymmetries, so differences between left and right. By the age of 2, most children display a clear preference, and brain imaging suggests both-handedness, whether you're right-handed or left-handed, and speech lateralisation, meaning which half of the brain hosts your speech area, are largely in place by age 3. That word, lateralisation, is very important. In most people, the left hemisphere carries the heavy load for producing and understanding language, while the right side adds colour, tone, rhythm, emotional nuance. What's interesting is that motor and speech systems share overlapping networks for sequencing movements and sounds. Your hand and your tongue have more in common than you think. One clever study in children aged 3 to 10 used functional Doppler ultrasound to map blood flow in the brain. The results? Kids with smaller skill gaps between their hands were more likely to show classic left hemisphere language dominance, while those with bigger motor asymmetries were more likely to have atypical right hemisphere language. So how evenly skilled your hands are may reflect how your brain organizes speech itself. It's not nature versus nurture, it's both. Large data sets like the UK Biobank show that early life factors, lower birth weight, being part of multiple birth, season of birth, not being breastfed, being male, each nudged the odds slightly towards left-handedness. But these influences are tiny. Even taken together, they predict very little. Genetics play a role too, but handedness is only weakly heritable. Biology essentially sets the stage, experience fine-tunes the outcome. And culture has left a real mark. For much of the 20th century, left-handed children were routinely corrected. Teachers forced pens into their right hand, treating left use as an error to be fixed. The prejudice was built into language itself. The Latin sinister, English sinister, simply meant left, but over time it morphed into unlucky or evil. One of my old mates from Italy had his primary education from nuns. He was born left-handed but was physically forced to use his right hand. They tied his left one behind his back. As those attitudes softened over years, decades, century, the reported proportion of left-handed people rose. But here's the fascinating part. Brain imaging shows that converted left-handers, people forced to switch, still show more bilateral, both sides of the brain, activation when writing than natural right-handers. The brain never fully forgets its original preference. You might ask, what's so special about the right hand? Why are we mostly right-handed? Why right-handedness at all? This isn't just a human quirk, but humans are extreme. If you look at comparative studies across primate species, it's found that our level of population-wide right-handedness is unmatched. We are unique. Other primates often have individual preferences, but they rarely show the kind of species-wide bias that we do. The best explanation is that modern humans evolved under both cooperation and competition. Tools, weapons, and social conventions favored right-handers, creating pressure to conform. At the same time, maintaining a small pool of left-handers may have offered strategic advantages in unpredictable encounters, which is why left-handers are overrepresented in combat sports and ball sports, where they catch right-handers off guard. Tennis gives us a perfect illustration. Take Rafael Nadal, one of my all-time favorite. He was born right-handed, yet his coach, Uncle Tony, made the deliberate decision to develop his left-handed game from the start, from when he was very little. That single strategic choice eventually produced one of the sport's most devastating weapons, a forehand that kicks viciously into a right-hander's backhand on clay, and it brought us a record 14 Roland Garros titles to prove it. The important point I'm trying to make today is this. Handedness is the product of biology, development, and culture working together. It's not a fixed, immovable property of the brain. Our brains remain plastic. Even in strongly lateralized species like ours, practice can shift the balance, which is exactly what makes non-dominant hand training possible. The more you deliberately practice with your non-dominant hand, the better it gets. And not just a little, the gains can be dramatic. Several randomized trials, these are studies with the highest level of evidence, have tested this directly. In one study, right-handed adults trained with a computer mouse using only their left hand. 15 minutes a day, 5 days a week for 6 weeks. By the end, their left-hand performance improved by 31%. But here's the part that caught my attention. Their right hand improved too, even though by only 13%. This is called bilateral transfer. Training one side of the body benefits the other because motor learning isn't locked into one hemisphere. Another study asked participants to learn chopsticks with their non-dominant hand. After 6 weeks only, their skill was almost indistinguishable from their dominant hand. And in a precision drawing study, 89% of participants showed measurable improvements after just 10 days. Even more impressive, most of them retained those gains 6 months later. However, not all practice is equal. In a randomized controlled study, general daily activity training in household chores with the non-dominant hand did not significantly improve dexterity compared with the specific structured exercises requiring fine motor control. The gains come from deliberate, task-specific practice, not just switching hands for random activities. So let me walk you through the 4 strategies with the strongest evidence behind them. Strategy 1, is called structured progressive practice. This is the cornerstone. Everything else builds on it. Begin with simple tasks where safety is not a concern. Stacking coins, screwing jar lids, stirring coffee, brushing your teeth. Do them slowly and deliberately with your non-dominant hand. Don't start by carving a pumpkin. Don't use sharp tools. 10 to 15 minutes a day is a good starting point. Consistency matters more than intensity. The research consistently shows that sessions of 10 to 30 minutes, repeated daily or almost daily for 2 to 6 weeks, produce measurable improvements. Focus on quality of movement. Watch your hand. Pay attention to how it feels. Break complex tasks into steps. Writing letters, for example, involves grip, finger movement, and wrist control. Practice individual strokes before writing full words. Then increase complexity gradually. Once you can stir your tea without catastrophe, try pouring water, drawing simple shapes, or using chopsticks. Progress to cutting food with a knife in the non-dominant hand. And use what we call distributed practice. Shorter sessions spaced out over time, rather than cramming everything into one long block. Your brain needs gaps between sessions to consolidate what it's learned. If daily practice isn't realistic, 20 to 30 minutes 3 times a week still works. Key isn't how long you train in one sitting, but how regularly you come back to it. Strategy 2 is called mirror training. It's one of the most fascinating tools in motor rehabilitation, and it's directly relevant here. Mirror training was originally invented to help people with phantom limb pain after amputation. The idea is simple. You place a mirror between your arms so that when you move your dominant hand, the reflection makes it look as though your non-dominant hand is performing the same movement with equal control. That visual feedback activates motor circuits on both sides, essentially tricking the brain into rehearsing the movement for the weaker hand. Since its introduction, mirror training has been used for stroke recovery, for traumatic brain injury rehabilitation, and athletic skill development. One leading explanation for this kind of mechanism, this kind of training, is that it taps into the brain's mirror neuron system. These are cells that fire both when we perform an action and when we watch someone else do it. Brain scans show that mirror training not only activates motor areas but also boosts visual areas linked to the opposite limb. It's a bit like seeing a rehearsal tape of what your weak hand should be doing. Once the brain can picture the movement clearly, the body is far more likely to execute it. So how do you do it? You place a mirror vertically on a table so it hides your non-dominant hand but clearly reflects your dominant one. You can hold a pen, a tool, or a utensil in both hands simultaneously. As you move your dominant hand, the reflection creates the illusion that your non-dominant hand is moving with the same control. And in fact, it is moving alongside it. Begin with basic symmetry drills. Trace shapes, draw straight lines. Do slow wrist movements with both hands together, keeping your eyes on the mirror image. Keep sessions to 10-15 minutes, 3 to 5 times a week. Focus on smoothness and accuracy, not speed. And the best part of this, it's cheap, it's simple, and you can do it anywhere with a button mirror and a flat surface. Strategy 3 is called motor imagery. It means mentally rehearsing a movement without physically performing it. This can improve performance, especially in the early stages of learning. Studies on sequential tapping tasks show that imagery practice produces some transfer of skill to the opposite hand. But imagery alone has limits. When practice is prolonged, physical execution outperforms imagery for bilateral transfer. What does it mean? That you should use it as a primer, not as a replacement. So the practical approach is spend a few minutes before each physical session Visualizing the movement in as much detail as possible, you can close your eyes. Feel the muscles contracting, see the path of the object, picture the grip, the pressure, then immediately perform the movement. This primes neural circuits and can accelerate training. You can also try writing your name with both hands simultaneously in mirror image. It's incredibly frustrating, believe me, but evidence suggests that such bimanual tasks increase interhemispheric connectivity, the communication between the two halves of the brain. A study with handball players found that mental practice of the non-dominant hand improved performance of the both trained limb and the opposite limb. The combination of imagery and physical practice consistently outperforms either one alone. Strategy 4 is called visual feedback training. This one is subtle but powerful, and it's often overlooked. In a 2021 study, researchers tested two groups learning to trace with their non-dominant hand. One group got persistent visual feedback. They could see the entire line they were drawing as they went. The other group got non-persistent feedback. The line disappeared as soon as it was drawn. Only the persistent feedback group showed real gains in accuracy. Being able to see your mistakes in real time lets the brain continuously adjust, building a more accurate internal model of the movement. Think of this like training wheels. The constant support helps you learn the correct pattern. But once your brain has internalized it, you take the wheels off. So how to apply this? You print or draw a simple shape, a circle, a star, letters, and trace these slowly with your non-dominant hand. Use tracing paper or overlays so you can always see your previous line. Focus on accuracy first, speed later. You could film your hands as you practice, then play it back and look for drift, instability, or postural problems. Once you improve, try removing some of the visual cues. Switching between full and partial feedback forces your brain to internalize the pattern rather than just copying the line. The gains are real, but they need maintenance. Here's what the evidence says about keeping them. Incorporate your non-dominant hand into daily life. Open doors, carry bags, use your phone with the weaker hand. These micro practices maintain neural pathways without demanding extra time. Revisit structured exercises periodically. Once your initial training phase ends, run a maintenance week every few months. A few days of focused practice to refresh the skills. And importantly, listen to your body, really. You don't want to get injured. The non-dominant side is more prone to awkward postures and strain. If you feel discomfort, modify or pause. And remember, even if your performance dips after a break, it does come back faster than it took to build the first time. That's neuroplasticity at work. The pathways don't disappear, they just need reactivation. Let me bring all this together. Handedness is deeply rooted in our genes, our brain architecture, our evolutionary history, but it is not fixed. The same neuroplasticity that allows stroke patients to relearn movement, that allows musicians to develop an extraordinary bilateral skill, is available to all of us. The evidence says structured, deliberate practice of 10 to 30 minutes a day over several weeks will measurably improve your non-dominant hand speed, your accuracy and smoothness. Mirror training, motor imagery, and visual feedback training can each accelerate the process. And perhaps most surprisingly, training your weak hand makes your strong hand better too. So, whether you're a surgeon looking for finer bimanual control, a musician wanting balanced hands, an athlete chasing an edge, or someone who just enjoys a challenge, neuroscience supports you. Your non-dominant hand is not a lost cause. It's an untrained asset. Now, if you'll excuse me, I'm about to play my old tennis coach. He still isn't remotely worried about me. But he doesn't know about my secret weapon.